Hello students, and welcome back to another geometry video. You know what to do. Pause the video and try this problem in your notes. You are taking a proof and you're going to fill in some of the blanks that are missing. So make sure that you understand what you're given, understand what you're trying to prove, convince yourself that yes, this is true and this can be proven, and then unpause the video and let's go through it with me. Okay. Complete the two-column proof. Given AB is the same as DE, okay, that's why they put the tick marks there, that's good. Given that BC is the same as CD, beautiful, they put the tick marks there. So everything that's given has been marked on our diagram, that's good. We want to prove that AC is the same as CE. Oh, okay, this is similar to a proof we've seen before. This chunk and this chunk are the same, this chunk and this chunk are the same, so you have two, this is like when we had a green and a blue chunk, and a green and a blue chunk over here. Still, the green chunks and the blue chunks are the same, so yeah, of course these are going to be the same. Okay, I'm convinced. So first, we have our givens, then we have AB plus BC is equal to BC plus DE. Wait a minute. Okay, you have lost me. AB plus BC congruent to BC plus DE. Addition property of equality. Oh, okay, so what they did, they took this and they added BC to both sides. Okay, I was like, how is that the addition property of equality? There we go. Okay, so they took this statement and they added BC to both sides, and as long as I add the same thing to both sides of the equation, that's okay. They are equivalent equations because of the addition property of equality. That feels good. Now, substitution property of equality. Let's see. So what would I need to write here in order for that to be using the substitution property? Well, let's see. I know that BC is the same as CD. So maybe they have AB plus BC equals CD plus DE. Let's see if that makes sense. I feel like they could have done that. They could have, but let's see if that makes sense. That would be using the substitution property. Let's see if that makes sense. So their next step is that AB plus BC equals AC. AB plus BC equals AC. And let's get a different color. CD plus DE equals CE. Oh, okay, both of these things are because of the segment addition postulate. Segment addition postulate. Okay. And let's see. We have... Oh! This was right. We were right when we did this because... Check it out. AB... I'll do my colors again. CD plus DE, that's CE. And AB plus BC, that's equal to AC. So now we can say that AC is equal to CE. And that's the substitution property again, because AC is this and CE is this. Beautiful. Okay. And now from here, how do they get from AC being equal to CE? How do they get to the segment AC is congruent to the segment CE? Well, that's what it means for two segments to be congruent. If they have the same length, then they're congruent. So this is definition of congruent segments. And there we go. We filled in all the blanks. and this proof, so it's not just, oh, I filled in all the blanks, I'm done. No, we filled in the blanks, and this makes logical sense when you go through each of the steps. So, yay, good job. Good job to all of us. All right, today we are on part 2 of section 2.6, proving geometric relationships. And now, our learning target is that you know what paragraph proofs are. And the success criteria is that you can write paragraph proofs. Now, paragraph proofs to some people are the easiest because of what a paragraph proof is. A paragraph proof is a style of proof that presents the statements and reasons, so you still have statements and reasons, but you present them as sentences in a paragraph, using words to explain the logical flow. So instead of a T-chart, or instead of boxes with arrows, you're just writing a paragraph proof. So this is what one looks like. It just looks like a paragraph. It's a lot of words. It's not a ton of math symbols. So maybe if you're like, Miss Dodge, I can explain this in words, but I can't do all of like the math speak that you're telling me. Maybe paragraph proofs are for you. And a tip for paragraph proofs, we're going to talk more about this later, but transitional words such as so, then, and therefore help make the logic clear. And you'll see if you ever look at my college notebooks when I'm like trying to prove things on my own, I use a lot of so this. Then this happens. Thus, we can tell. Therefore, this happened. Like, that's a lot of, because of this, then I can say this. That helps show, like, your statements. Remember, your statements are like, I'm saying this because of this. And, like, from one step to the other, like, if I'm talking about step 2, then, like, I say step 1, and then I can conclude step 2. So then kind of tells you that we're done with step 1 and we're moving on to step 2. These transitional words tell you that we're moving on to a new step. Okay, so that's what a paragraph proof is. Let's look at some more postulates and theorems, because we're gonna use them in proofs, and we're gonna look at them. We're gonna prove one of them. So, the linear pair postulate. Remember, postulates don't need proof. These don't need proof. We accept them. We say, yeah, that makes sense. I know that's a thing. Theorems need proof. So a lot of the things that we prove in this class are theorems, and postulates we won't prove because we don't need to. And sometimes you can't. We just assume. This is an assumption that we all agree to make, and it can't be proven sometimes. Okay, so the linear pair postulate, we'll look at this one first. If two angles form a linear pair, then they are supplementary. We don't need to prove this. This is something that we accept because a linear pair makes a line, and that's what a straight angle is. A straight angle is a line. So, duh. If you have two angles that make a line, they're going to be 180. Duh. No proof needed. Okay. Next, we will talk about the vertical angles congruence theorem. Here we said vertical angles are congruent. And we talked about this back when we introduced vertical angles with our special angle pairs. We said that vertical angles are congruent, that angle 2 is congruent to angle 4, and angle 1 is congruent to angle 3. We said that, but actually this can be proven. This can be proven, and we're going to do that in the next slide. So we're going to use, here they have given us a paragraph proof of the vertical angles congruence theorem. We are supposed to use this paragraph proof to write a 2-column proof. So, we're going to have statements. We're going to have statements and reasons. And we're going to use this paragraph proof to come up with our statements and our reasons. So first, let's make sure that we understand the paragraph proof. Here's our diagram. I'm going to make these a little bit bolder. We have, looks like an airport runway here. So angle 5 and angle 7 are vertical angles formed by intersecting lines. As shown in the diagram, angle 5 and angle 6 are a linear pair. And angle 6 and angle 7 are a linear pair. Then, by the linear pair postulate, angle 5 and angle 6 are supplementary. Because they make a line together, they are supplementary. Because they're a linear pair, they are supplementary. And 6 and 7 are supplementary because they make a line together. So by the congruent supplements theorem, we talked about that in the last video, angle 5 and angle 7 are congruent. Okay. This paragraph proof makes sense to me, and we went through it kind of slowly, but if it's still confusing to you, please, I encourage you to pause the video, reread this paragraph proof, and really try to understand each sentence in the proof. And if you don't, if you're like, I have no idea what's going on here, ask your teacher for maybe more detail, and maybe they can walk you through it step by step in like a one-on-one Google Meet or conversation. Okay, but we're going to start our paragraph proof. So, 5 and 7 are vertical angles formed by intersecting lines. That's what we are given. So, angle 5 and angle 7 are vertical angles. Reason for that? It was given to us. Okay. As shown in the diagram, 5 and 6 are a linear pair, and 6 and 7 are a linear pair. That looks like the next step for me. 5 and 6, angle 5 and angle 6 form a linear pair. And in fact, I'm going to put these in the same step. Angle 6 and angle 7 form a linear pair. What these marks mean right here is it means everything above it. So when I write these marks, I'm saying form a linear pair. Just write everything above it comes down. Okay. Angle 6 and 7 form a linear pair. Notice how it said, as shown in the diagram. So we can say given, because it's in the diagram. We can also say, like, intersecting lines, because of the intersecting lines, this happens. So you can say given, or you can say, like, because of the intersecting lines. Whichever one of those you want to say. And the reason I put these in the same step is because they have the same reason. And I didn't want to write the reason twice. Okay. So step 3, let's see. By the linear pair postulate. When it says by the linear pair postulate, I can tell that that's my reason. The linear pair postulate tells me, and what does it tell me? It tells me that 5 and 6 are supplementary, and 6 and 7 are supplementary. So that means that measure of angle 5 plus the measure of angle 6 equals 180, and the measure of angle 6 plus the measure of angle 7 equals 180. Woo! We are getting cramped in here. And that is the linear pair postulate and the definition of being supplementary. We kind of combined two steps in one. Definition of supplementary angles. Okay. Next, the congruent supplements theorem tells us that angle 5 is congruent to angle 7. Ah, okay. That is the end. So we actually didn't even need to write it this way. We could just say that they're supplementary. And angle 5 is congruent to angle 7 because of the congruent supplements theorem. So this proof was a lot easier than I thought it was going to be. We just got to use the congruent supplements theorem. This is why you prove theorems. When you prove theorems, you can use them as reasons. If you haven't proven the theorems over here, you can't use them. If they're postulates, then remember we don't need to prove them, and we can use postulates, definitions, and proven theorems. Those are all the things we can use as reasons. Okay, let's check our answer, and I have a feeling that they'll have wrote it a little bit more eloquently, because instead of writing this, we wrote that the measure of angle 5 plus the measure of angle 6 equals 180. I thought we were going to have to do this. But because we did this when we proved the congruent supplements theorem. So we don't even have to, write all this out because we already did that inside of another proof. So we don't need to redo the proof of the congruent supplements theorem. We can just use the congruent supplements theorem. So all they did was they wrote this instead of measure of angle 5 plus the measure of angle 6 equals 180. Okay, beautiful. Yeah, definition of linear pair as shown in the diagram. So you can say in the diagram, given, you can say all that. Beautiful. Okay, we're gonna step away from proofs for just a second, because the book kind of tells us to, but also we want to be able to use. You have just you have just proven that vertical angles are congruent. So now we're gonna use these angle relationships that vertical angles are congruent. We're going to use this relationship. This problem tells us to find the value of x. And but look at that. These are vertical angles because they are formed by two intersecting lines, and they are on opposite sides of those intersecting lines. So because these angles are congruent, it means that their measures are the same. So, if their measures are the same, we can set them equal to one another. Now we just need to solve this. I know I'm going a little bit fast, but I think I can trust that you know algebra. If I am going too fast, you can change the playback speed of the video, or you can go back and freshen your algebra skills using some of the videos in the algebra videos playlist. Okay, so we do our algebra and x equals 9. Are we done? Yes, we are, because it just told us to find the value of x. It didn't say find the value of angle QPR, but we already know the value of angle QPR. It's 148. So they just told us to find x. We found x, so we're done. And we can check our answer. Yeah, look at that. Definition of congruent angles. And you can see every time I show you one of these solution slides, and these are from the online Big Ideas curriculum, but you can see that they kind of prove, like they always tell you like what they're doing when they do the problem. They always give you the steps and what they're doing. This is kind of like a proof. Subtract 1 from each side. Subtraction property of equality, etc., etc. But they got 49, so did we. We were right. Yay for us. Okay, so now, last example for today, last one. We are going to use the vertical angles congruence theorem in another proof. So because we proved the vertical angles congruence theorem, we can use it as a reason. Now that we have proven it, we can use it as a reason. So I am given that angle 1 is congruent to angle 4. Let me use a different color because the red is blending in. So angle 1 is congruent to angle 4. And I want to prove that angle 2 is congruent to angle 3. Do you believe this? Do you believe that 2 is congruent to 3? Well, 1 and 2 are vertical angles. So because they're vertical angles, 1 and 2 are the same, right? They're formed by intersecting lines, so 1 and 2 are the same. And then 4 and 3 are also vertical angles, and vertical angles are congruent, so that means 3 is congruent to 4. So you can see from this diagram, look, all the tick marks, the tick marks show you that angle 2 is congruent to angle 3. So yeah, I believe it. I believe angle 2 is congruent to angle 3. So now I'm going to take us back to what we're given. We're given that angle 1 is congruent to angle 4. And now we need to write a proof with this information. So, we are given, and because this is a paragraph proof, I'm just going to write a paragraph. We are given that angle 1 is congruent to angle 4. The diagram shows us that angle 1 and angle 2 are vertical angles, and angle 3 and angle 4 are vertical angles. The vertical angles congruence theorem, vertical angles congruence theorem tells us that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, because they are vertical angles, and we said that in the last sentence. Remember that we were given that angle 1 is congruent to angle 4. So, by the transitive, property of congruence, we know angle 2 is congruent to angle 4, and thus, so angle 1 is congruent to angle 2. Let me explain this. Angle 1 is congruent to angle 2. Excuse me, angle 4 is congruent to angle 1, angle 1 is congruent to angle 2, so angle 4 is congruent to 2. And because angle 4 is congruent to angle 2, angle 4 is also congruent to angle 3. So thus, angle 4 is congruent to angle 3. And a fun thing that you'll see if you go on to higher mathematics, when we are done with a proof, we draw a little box and we color it in. And that's my favorite part of proofs, is drawing the box. The reason that we draw the box is because in math textbooks, when you get to higher level math, you are writing tons of proofs. Like, there are so many proofs in these textbooks, because in order to accept something as true, we need to prove it. So you can't just say this without proving it. So there are a lot of proofs in math textbooks. And how do you know when the proof is done and we've started talking about something else? Well, you see this box. If you see this box, it means that the proof is done. So that's my favorite part of drawing proofs, because it means I'm done. When I color in that box, it means I'm done. So we can check our answer. Angle 1 and 4 are congruent, given. By the vertical angles congruence theorem, angle 1 is congruent to angle 2, angle 3 is congruent to angle 4. By the transitive property of angle congruence, angle 2 is congruent to angle 4, and then the transitive property again tells us that angle 2 is congruent to angle 3. Sounds exactly like what we did. Yay! Okay, so to summarize, we gotta zoom out a little bit. To summarize, chapter 2.6 and 2.5 actually, we learned about two-column proofs, we learned about flowchart proofs, and we learned about paragraph proofs. Unless a question tells you write a flowchart proof, you get to decide. If something tells you prove this, you get to decide. Do you want to write a two-column proof? Do you want to write a flowchart proof? Do you want to write a paragraph proof? So be familiar with all of them, but typically you get to choose how you want to prove it. Now here is the symmetric property of angle congruence. They proved that theorem, and they proved it using a two-column proof, using a flowchart proof, and using a paragraph proof. So you can see that they proved the same thing, they just did it in 3 different ways. So you can look at that for an example of each different type of proof. Okay, but that is everything that I have for you for chapter 2.6. Congratulations on finishing the end of chapter 2. And if you have any questions at all, please, please, please talk to your teacher, talk to a friend. Proofs might be the most frustrating or hard to learn thing in math, but they are the most important. This truly is the reason that we learn math, is because of this logic and reasoning skills. So I really, really want you to understand this. Practice problems. These are like example 3, these are like example 4, and we also have problems that are like example 3 and example 5. So try your hand at these problems so that you can perfect the skills you've learned in this video, but also be sure to do the homework that your teacher has assigned as well. And as usual, we're going to end this video with a launch. This launch comes from Jim Rohn, and he says, "Happiness is not by chance, but by choice." Not chance, by choice. Not by chance, but by choice. Now, before I begin talking about this, I want to preface it with depression and like mental illness, mental health is real. So don't let people just tell you, oh, you just need to be happy. Oh, you just need to choose to be happy. Like, no, there are some times where physiologically, your brain cannot choose to be happy. And in those cases, there is absolutely no shame in getting help. Antidepressants are not bad if you need them, if they help you. You don't want to stay on them for your whole life, of course. You want to be able to get to a point where you don't need them. But if you need them, there's no shame in getting them. So I want to preface this by it's not always possible to just choose to be happy. But oftentimes it is. So that aside, if you have a mental illness, if you struggle with mental health, please get help. It's not bad to have a mental illness. I technically have one. It's not a bad thing. You can still be smart. You can still have a job. You can still be a normal human being with a mental illness. So it's not a bad thing. Get help for it. It's not a bad thing. And don't let anybody shame you for it. That being said, there are a lot of times where you can choose happiness. I talked about that cup that I broke. It is still on my mind for some reason. But I could have chosen to cry over that cup and to be really upset, or I could choose, you know what? I'm going to choose to say that this cup didn't matter that much to me. I'm going to choose that. I could choose to say, no, this cup was the most important thing to the world to me. And I could choose that too. But it is up to you. It's up to you to choose how you want to feel. And there are times where we want to choose to feel sad. If your boyfriend dumps you, you want to choose to feel sad. Otherwise, maybe your relationship didn't mean as much as you thought it did. Or maybe you just want to choose to be happy. You're like, nah, I'm done with that doofus. I'm going to choose to be happy. But you get to choose. And there's nothing wrong with choosing one or the other, but choose what you want to choose. Choose happiness or choose to be sad. But know that it is your choice. Mental illness aside, it's your choice. So, choose happiness, except for the times, like if your grandpa dies, you probably want to choose to be sad, right? I did when my grandpa passed away. So yeah, you can choose to be sad or you can choose to be happy, but the choice is up to you. That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thank you for being here. Thanks for watching. Bye.